तो दोस्तों शुरू करते हैं विदाउट वेस्टिंग ए टाइम. इन द लास्ट वीडियो वी हैव सीन हाउ वी कैन अप्लाई different type of filters just to do by doing the drag and drop, and we can apply the filter key. In this video, let's see. I have on this file, and one of the troublesome or one of the thing we have to find out there what are the packet related to the one stream, like on the TCP connection, what are the things are, what are the packets got exchanged between the two endpoints we need to find out. So how we will be able to find out that stream. Okay, like we know in the TCP three-way handshake, okay, majorly two flag play important role: SYN and SYNAC flag, SYN and acknowledgement flag. First packet will the SYN, then the other side SYNAC will come, then ACK will come. So this way, three-way handshake in the TCP will got complete. So what we can do is, if I apply a filter like if I type TCP, then after a dot, so it will start showing the option. Let's go with the flags. Okay, FLH flags. Then after that, we can put the flag name dot and put the flag name, then is equal to one. Okay, and then and similar way TCP dot flags dot ACK acknowledgement is equal to one. So by doing this, we can apply the filter. It will show the packets with packet having a both the flags are set. Sin is equal to one, acknowledgement is equal to one. Okay. So I put this flag. Okay. From here we can see that these are the packets in which these both flags are set. Okay. So if I put this here, if I right click on this and apply this follow, here we have once we click on the right click of the packet, you will get the follow. After the follow, you need to go to the TCP stream. So what Wireshark will do, now it's showing all of the packet which got exchanged between the two endpoints on the these ports. So with the help of this follow TCP stream, we will be able to find out particular packet which got exchanged with the two IP and their source and destination port. And if you want to check the what are the options are supported in the TCP handshake from the both of the endpoints, like we have a source IP 192.168.1.6 and destination IP 6400.12.57. Where select this packet. Here, if we come on the this TCP transmission control protocol, under that in below options we have once we go under the option, we have these are different type of option which supported by this source IP 192.168.1.6. It's sending a maximum segment size with the 1460 bytes, and Windows scales factor is supported, and also it's supported a selective acknowledgement. Similar way, if we click on the second packet, where the source now is 6400.12.57, in this also you can see that this host is sending a maximum segment size will be the 1380 bytes, and selective acknowledgement permit, and this is the Windows scale factor. So once both of the side support the selective acknowledgement and Windows scale, then only they will be able to use it. So both have to support this feature, and MSS will be the different on the each end. There is no negotiation required in the case of MSS. MSS will be different. As we have seen in the Wireshark in the TCP options, correct? So we have seen one field is MSS. What is MSS? MSS is the maximum segment size for the TCP. So you can say it's an MTU minus header. Okay, header for the TCP header and IP header. So both of the header will length will be 20 bytes. So total with the 40 bytes. So if link MTU is 1500, so MSS will be 1460. 1500 minus 40, 1460. Okay. And one of the question can be what is the difference between the MTU and MSS? You can say. Okay. So MSS is actual the length of the packet without the TCP header and IP header. Correct. And if our packet length will be the more than the link MTU, then packet will be broken into small process, and this process is called a fragmentation. Okay. And one more difference is if packet will exceed the MSS value, if in between the router on the router MSS is let's suppose is 1500 and packet is coming for the 1600, in that case packet will drop. It will not be fragmentation. Fragmentation happen in case of MTU, correct? If that MTU packet size is total packet size less than or greater than MTU. Okay, so this is the key difference. While packet exceeds the MSS is good drop, this will not delivered. Okay, and if here you can see that if we have a link MTU, what is the MSS you can configure that router. So again, link MTU 1600. So after subtracting the TCP header and IP header. So 1560 will be the MSS value we can confirm the router. Okay. And one more thing you will see in the Wireshark, if you will be able to send a packet with the more than the link MTU, so you'll get the message. The router not able to forward the packets, what will do? And let's suppose if we have in a case where the router is not able to forward the packet and packet length is more than the link MTU, and in the IP field in the IP header we have one field is fragmentation bit is set, means that packets not to be fragmented, so not to be divided into small pieces. In that case, what router will do? Router have to generate a ICMP destination unreachable message to the source of the packet. Let's suppose this router one is trying to send a packet of the to this destination with the M2 length is packet size total length is, which include the TCP header, IP header 1600 bytes, but the link M2 here between the router 3 and router 4 is 1500. Okay, and also in this packet fragmentation bit is set. Don't fragmentation bit is set. So this router will not be able to do the fragmentation. It will not break the packet in small pieces. What this router have to do? This router have to generate a message ICMP destination unreachable message to this source router from where the packet is got generated from this packet is coming to for this R1. Because once the source router receive this ICMP destination unreachable message, then only he can think about to reducing the MTU, correct? As the fragmentation, don't fragmentation bit is set. But if we have a file in the path and file dropping this ICMP packet, in that case, this can be the problem. So in few of the server, we have an option where we can enable the another options to discover the MTU. Okay, like we have a smart MTU block hole detection on the server we can do. There are multiple options we can do. So these are the different things we have to take care about them. Here you can see in the Wireshark, here we have a TCP header. This is transmission source port decimal. This is the IP header. Okay, in the IP header, if we click on the IP header, here you will decide that we have this fragmentation field. Okay, don't fragment, and this field will be set to, like here we have an dot will set. It will show that dot fragment is set, so this will not break the into small pieces. Okay, once this bit is set. So let's see this IP fragmentation part into action. So I am capturing the packet on this interface router to it 0/0 and 0/1, both of the interfaces. Okay, and both of the interfaces I have set the IP MQs to 1000. Okay, so let me show you the configuration. So here we on the router 2, I have set the IP MQ on both interfaces. Let me show you the configuration on the 0/0. You can see that IP MQ 1000. Similar way, both the interface we have set with this command IP MQ. Okay, same thing. You can verify. Here you will see that MQ is 1000 byte. We have set it. Okay, so let's jump to the router 1 for the ping. So here we on the router 1. Let's ping the destination 6.6.6.6 and source is 1.1.1, and here we are getting a size. Okay, let's suppose I set the size for the packet is, we have put the link M2 is 1000. Okay, and here I'm setting the DF bit. Okay, so this will ping. Okay, similar way, if you will increase the size, now the M2 we have set is 1000, so this will not ping. You can see that we are not able to ping, we are not getting any response. Okay, but if you keep the size less than with the DF bit set, fragmentation is not required bit set, you are able to ping that. Similar way, if you remove the, let's suppose I'm sending a packet with this cipher byte, but I'm not setting the DF bits. So when I'm not setting the DF bit, means router will be able to do the fragmentation, so you're able to ping. Okay, so let's see similar thing in the Wireshark capture. So here we are on the Wireshark capture. Okay, so let's filter the ICMP packet. I'm putting the ICMP, so this will filter all of the ICMP packet. Okay, and here you can see that this is the first packet. Okay, here we can see that if I go to that packet, it's showing response in the 87 frame, and here you can see the 972 byte. Okay, the first packet which we have sent with the length of 1000 byte. So actual data is 972, as the ICMP header is length is 8 byte. So 972 plus 8 is 980, and 20 byte is our IP header. Okay, so total packet length will be on the 1000. Okay, and if you go to the here in the IP packet, you will see that here we can see that not fragmentation. So okay, here we have an DF bit is set. Okay, this was the first packet. There the 5 responses are there. Okay, and here this is another packet. Here we can see. Okay, let's see this packet also. Here's the now data length for the packet is 973, as you are ping for the 1001. Okay, so one again 973 plus 8 byte for the ICMP, it will become the 981 plus 20 byte for this IP header, it become the 1001, as the link MTU was the 9000 1000 only and not 1001. So this packet got dropped as the DF bit was set. Okay, as we have seen that when the DF bit was set, and a router is not able to do the fragmentation, so what the source router do? So this is the router. Okay, this is the router to interface IP is generating a message, destination unreachable, fragmentation needed. Okay, this is the message needs to be generated by the router, where the router is not able to do the fragmentation as DF bit is set. Okay, and let's come down. Here you will see that this router, yes, this packet here you see this one. Here we are sending now packet with the length is 1472 bytes, and if we go to the IP header, here you see that DF bit is 0. So we are not setting the DF bit. This is the reason we are able to ping with the 1500 size packet also. But actual length of the data is 1472, again 8 byte for the ICMP header. So the 1480 plus 20 byte for the ICMP, total length will be the 1500. Okay, and if you see this, this is our request. Okay, if you see the response, this will show in the response fragmented part how this break the packet into two pieces. So here you see that in the IP header you have to go under the IP header below two IP for fragment. So it's breaking a packet. One packet is the 0253, second packet is 5042 to 179. As the link M2 is only 1000 and DF bit is not set, so router have break the packet into two pieces. One become the 504 byte, another become the 976 byte. Okay, and this is the capture we have taken from the incoming interface. So in this capture we will be able to see that incoming ICMP request also. I show the ICMP reply where the fragmentation was happening. In similar, take this. Here we have an request. This is the 154 reply. So this is here. So this packet request is going. Response in yes, response in 119, and in the response in the request packet also, here you can see it's breaking the packet for the ICMP request packet also, and for the in the reply also you will see the reply we already shown on the outgoing interface of the router. Okay, so here this is the incoming interface which we have taken the capture. In the request also you can see that immediate router got the packets, you break the packet into small. Here is the fragment count, here is the telling the length of the first packet, second packet. Okay, let's see MSS also in the action. Let's see how MSS got changed. Okay, so on this router 2, on this it 0/0 interface, I have configured the IP TCP MSS is the 500. Okay, and we are taking two Wireshark capture. One is from the router 1 is 0/0 interface, one from the router 6 interface is 0/0. Okay, and what we will do, we will try to establish a telnet connection from this router 1 to router 6, and after the exit connection, what we'll see, In this capture, when this router one will try to establish a telnet connection, it will send a sync. In the SYN packet, in the TCP SYN packet, we will see TCP MSS value, it will send the 536. While on the same capture, on the receiving side, we see TCP MSS value will be the only 500. Similar way in the vice versa. Here we'll also see in the second packet within the same act, while R6 will acknowledge the packet and reply with O1 SYN packet. So here in this capture file, we see that the TCP MSS will be the 500. We on the router 2. Let me quickly show you what is the command required if you want to configure it. The global also you can configure. Here I put on the interface Ethernet 0/0. This network connected with the router 1. I put the IP TCP MSS value is 500. So here we are on the router 1. Let's try to do the telnet to the router 6. Okay, telnet 6.6.6. Okay, let me put the credential, and after that I will exit the connection. Okay, let's go to the Wireshark. So here we are on the Wireshark file. Let's filter the packet in the TCP packet and selecting all. Okay, so here we are establishing a TCP connection. This is our SYN packet. Okay, we go here in the transmission in the options below. Here we can see that it's sending a maximum segment size is the 536, as this capture is taken from the router 1 interface. Okay. While in the second packet, this is the response coming from router 6 to this router, and here we can see that TCP MSS is the 500. As we have said, the TCP MSS on the router 2 interface connected with the router 1 is the 500. Let's take the same thing with the on the router 6 and interface capture. So this is our capture which we have taken from the router 6 and interface. Let me put the again similar way. Okay. Here again we check the SYN packet. In the router 1 interface, we are saying that router 1, when I initiate the packet, he was setting the TCP MSS 536. But as the incoming interface Havana, we have set the MSS is 500. So you see the MSS is 500 only. A similar way in the response in SYNAC, this router is already sending a packet with the MSS the 500. So this is how we can see that if the in between the endpoint in between any of the router is setting a lower MSS, so that you see that MSS will be code adjusted accordingly.